Let's start with a basic search. If the search box isn't already visible, you can click on the magnifying glass in the upper left-hand corner of the screen to open it. Type in a search query and hit enter to see your results come up. The first thing you'll notice is that search results are filtered into two main categories: artifacts and entities. Artifacts are results that are entire document, image, and video files. Entities are individual terms pulled out of these artifacts, either by an analyst or during the data extraction process. Click on an artifact or entity type to see the related search results. Clicking on a search result will bring up the detail pane for that item, which we'll explain in detail later. If we click back on the search box, the results list is replaced with the ability to add filters to our search. If we click on Add Filter, we get a drop-down with a list of all the properties that are currently defined. We can add multiple filters simply by clicking Add Filter again. To modify a filter, click on the title to change the search property. Clicking the title also gives you the option to remove the filter. The detail pane is visible on the right-hand side of the screen anytime you select an object. When we select an artifact, we will see the title and property list followed by the contents of that artifact. When we select an entity, the detail pane will show us its properties and relationships. From here, we can also add properties by clicking the Add Property button. Let's add a source property here and say we got this article from the LA Times. When we open the detail pane, we notice that there are many underlined portions which signify what we call terms. Inside an artifact, our entity extraction process makes a guess at what it thinks should be entities. These guesses are underlined, color-coded by the type of entity. We can click on the highlighting drop-down menu to adjust how the system signifies this information. While the underlining is the default, we can also view icons or full word highlighting. Because terms are just guesses, we can't actually do much with them yet. In this document, we see here a mention of Colombian President Santos. Since we'd like to know a bit more about him, we can click on him inside the artifact to bring up the entity resolution dialog. When we click in the text box, we see that there is already a President Santos in the system. Clicking on this first option will give us a new entity in the system with the name we've given it, while clicking here will say that this is the right person and resolve this term to the existing entity. Next, we click Resolve and notice that Santos is now in bold. This shows that he is now a resolved entity and can be dragged onto our graph. We can also resolve entities from text that wasn't highlighted as a term. If we select this text here, we are presented with the same dialog as before, only this time, if we select Create New Entity, we have to select the concept type of this entity. Let's take a look at the button next to Highlight. If you find an artifact particularly interesting, you can select this to open or download the original artifact. If you want to examine an artifact or entity with a little more screen real estate, you can use the last button here to pop out a new window. Let's say that I have two items that I want to compare side by side. I can now go to a second item and click the pop-up button again. This time, however, notice we have two options. The first one is what we did before, and we can open a new window for this document. Secondly, we could also append this document to the view that we just opened, so that these two documents will both be opened in the same view. Another way we can examine data from multiple documents at the same time is through our histogram view. If we click and drag to select multiple items from our graph, or multi-select from our search results, we see our detail pane will change slightly. At the top, we have a breakdown of the properties within the items we have selected. Clicking a document from the detail pane will allow us to examine it more closely without losing our multi-selection. Clicking on the currently selected item will return us back to the histogram view. Since most artifacts we've looked at so far have been documents, let's see what we can do with images and videos. When we import images into the system, we can define objects that we want to detect inside images. For example, we have facial detection running, and our extractor picked out this face here on the side. We can also individually tag anything in the picture that we want. For example, let's tag the sign here by clicking and dragging on the selection we wish to tag. When we let go of the mouse, we see that our entity resolution dialog appears. Let's call this an organization. We can now resolve the subimage just as we would resolve a term. We can also delete a tag by clicking this X here. Next, let's take a look at a video inside the detail pane. While at first it seems just like a property list in a video player, I'm going to point out a few cool features that videos have. Notice that we can move our mouse across the video player and our cursor turns into a red line. As the line moves, our video still frame changes to give us a preview of that position in the video. If we click at any point, the video will start playing from that frame. Below the video player is a full text transcript of the video. A video embedded with closed captions or separate closed captions file will have those shown here. The transcript will also consist of extracted text from individual frames of the video. These transcripts are run through our entity extraction process, and so as we scroll down, we will see some terms like we did in documents. Also, if we scroll over play the video, we see the transcript will scroll inside the video player. Both the scrolling player and full text transcript below work like other text we've seen so far, and we can resolve entities from either. When we open Lumify, our default view is the graph view. The graph is designed so we can visually explore and manipulate our data. Let's first get a few things onto our graph. There are multiple ways that artifacts and entities can appear in your graph, but the most basic is to simply drag and drop. For example, if I decide I want to take a closer look at one of my search results, I can click and drag to get it onto the graph. If we open the detail pane for this document, we can also click and drag any resolved entity onto the graph. Besides drag and drop, there are several menu options that place items onto the graph. We can right-click on an existing graph object to see that we have the ability to load related items. We can load all related items, or drill down into a second menu to select only related items of a certain type. Besides artifacts and entities, you've probably noticed the graph has also drawn some connections between items. These are relationships, denoting that this item is somehow related to that item. We can click on a relationship to view any properties it has. We can also create relationships from the graph view. Let me pull another article onto the graph. From this article, I'm going to click and resolve a location and drag this onto the graph as well. Let's assume that I know Luis lives here and we want the graph to reflect this. Right-click on Luis, select Create Connection, and click on the location again. I'm then presented with a drop-down of possible relations between a person and a location, and I'll select Lives At. A line denoting this relationship has now appeared. Another thing we can do on the graph is to find the shortest path between two items. I want to see if this person has any connection to a known terrorist organization. So I'll search for and drag the organization onto the graph. Then, if we right-click and select Find Path To, we can click on the second item to have the shortest path added to the graph. We'll start with a couple of items already on our graph from previous search results. Notice the items we've dragged onto the graph have two icons next to them in the search results pane. The first one is our graph icon and represents that we have placed these items on the graph. The second one is a map pin and shows that these items will be displayed on the map. Now, let's load our map view by clicking on the pin on our toolbox just below the graph icon. Any item on our graph that has the location associated with it will now appear on our screen. We can also drag items from search directly onto the map. If we try to drag an item that does not have a location associated with it, we see that the system recognizes this and will shake its head at us. From the map, we can also load artifacts and entities by doing a radius search. Since our current data set is about terrorist attacks in Colombia, let's do a radius search around that area. To do this, right-click on the map and select Load Results within Radius. We are prompted with the message, click to place the center of interest, which we do right where it says Colombia. Next, we can move our mouse outward and see a circle appear, showing the area that will be searched. I'll drag my mouse here, so it covers most of the country, and then click. We now see that our map has been populated with all the items that were tagged inside of that location. If we switch back to the graph, notice anything we've added to the map also shows up here. Let's play the role of an analyst. We've been assigned to investigate a recent bus hijacking in Medellin, Colombia. I've ingested data from local media and police reports about the hijacking, as well as a government listing of recent terrorist attacks in the area. We know that there are 3 active terrorist organizations in the area, and our goal will be to see if we can attribute this attack to one of them. Let's get an idea of what's been going on in the area that the hijacking took place in. We'll go to the map view and pan over to Colombia. Next, let's perform a radius search and pull back everything in a small radius around Medellin. Right in Medellin, we see a bus hijacking event, which is our attack of interest. Going back to our graph view, we can take a closer look at what else we pulled back. If we drag to select the events we pulled back, we can see a histogram view summarizing the properties of these events. The first thing that becomes very clear is that there is a good deal of similarities between them. All of the events come from our list of recent attacks made by the Guerrilla Terrorist Organization, or GTO for short. I also noticed that these attacks were of types hijacking and kidnapping. This makes me suspicious about the GTO already, but let's go down a couple other paths to see what other information we can dig up. I'm going to clean up our graph to just have our event of interest on it. We've been told that there are 3 terrorist groups we want to investigate. I'm going to search for each one so that I can pull them onto the graph. They are the Guerrilla Terrorist Organization, the Eco-Terrorist Organization, and the Shining Star Communist Party of Colombia. Since we have a profile for each of these organizations through the police, let's pop out a new window to compare them with the event. Looking at the Eco-Terrorist Organization profile, we see that they stress non-violence towards humans and animals. This is probably a flag that they are not responsible for the event. Next, the GTO, as we saw earlier, matches a little bit better. They are known for hijacking and extortion attempts, and aren't against violence. Lastly, the Shining Star seems to fall in the middle. Their profile doesn't stop me from thinking they could have done it, but nothing really points the finger at them either. Keeping this in mind, let's go back to our event. Clicking on the event, we see a list of artifacts that mention this bus hijacking. I'm going to right-click and load related artifacts to put them on the graph. Let's look through the artifacts to see if we can get a little better idea of what went on. A group of terrorists took a bus full of mostly Hong Kong tourists hostage in an attempt to extort a ransom from the government. When a desperate police attempt to subdue the terrorists was launched, 8 of the hostages were killed before they gained control of the situation. I'm going to see if we can pull back anything from search that we didn't find already connected to our event. Searching for hijacking is pretty broad, so let's add a filter to our search. I want to see if there's a police report about the event, so I want the title of my artifact to contain report. And here we go, a police report. The report gives us a name of one of the dead terrorists, Luis Mendoza. Let's drag him onto the graph and see what we can learn. Since this information shows that he was the perpetrator of the event, I'll create a connection here to symbolize that. I want to learn some more about Mendoza, so let's scan a couple of related artifacts like we did with the bus hijacking event. The first document tells us that he was the last person seen in the station's evidence locker before narcotics went missing. Next, we see an accusation from a fellow officer that Mendoza is stealing from the evidence locker. We also see mention of him meeting with a certain Pablo Garcia, who has known ties to the GTO. The last report details of an altercation between Mendoza and an officer, leading to him and 4 others to be fired from the force. So the pieces are starting to fit together, and we can see that this could have been a case of cop gone bad, leading into terrorist ties. Next, let's pull Garcia onto the graph as well, and we'll do some investigation onto him. As expected, he appears in the document overview of the GTO, as well as the report where we found him from. There's one more article here, so let's see if there's something new in there. Down here, the article says in passing that Mendoza and Garcia are cousins, something we haven't picked up on yet. Let's go ahead and create this connection in the detail pane. So to recap, we've managed to paint a pretty convincing picture here. We show that there were other GTO attacks in the area of similar type. We showed that this attack fit closest to the GTO in terms of our organization profiles. And lastly, we connected Mendoza, the one identified member of the attack, to the GTO. Therefore, acting as a police department, we can be certain that this attack was carried out by the GTO.